So this is the recap from the yesterday. This is basic knowledge but very important things if you want to work with LLM. For the generative AI, the basic concept of generative AI is they learn the pattern from the dataset in order for generating samples. This is the core idea. Depend on your dataset, you will have a corresponding new samples. For example, you learn a sample that is a digit, which is a digit, then you will try to generate a new samples, which is also a digit, that have a foreground is white and background is black. So it strongly depends on your dataset. And in practice, we have many applications of generative AI, such as image generation. This one is one type of image generation. You generate a new image from your dataset. The second approach is image extension, which is this one. Nowadays, if you use Adobe Photoshop, they already implement this function. So if you have the design team, you can use a new Adobe Photoshop and you can use this function that given a original image, you can ask generative AI to add more frame, to add more texture. This texture is new, it never exists before, it just learned from generative AI. The third application, that is text-to-speech. You're given a text and you want someone to speak for that text. You can have a voice of Donald Trump to speak that text, or the voice of anybody, as long as you have the data set from that person. And the last one, which also is a key founder of ChatGPT, that is sentence completion. Sentence completion that I mentioned, that is kind of word guessing games. You give it a long sentence, you ask generative AI to generate more text, and that text will depend on the text that you provide to the language model. Then because we are working with large language models, so most of the time we will talk about the language model, which is the foundation of the large language model. The language model, this is a word guessing game. Like I said, you have a sentence, the quick brown fox jumps over, and your task is try to generate a new word based on a given word. So given a sentence, your language model may predict 80% chance the next word will be the, 15% chance the next word will be a. So you think, okay, this there has a really high probability, the highest probability, so let's use the word the and put in here. Then your sentence will be like this. So let's say if your sentence is the quick brown fox jumps over the, so what is the next word? The next word, the machine say 60% is lazy, 50% is fence. So you pick the highest probability, which is lazy, and you place it here. Then you have a new sentence and you keep doing the process. The next word will be dog, and this is your output. Of course, you can predict more words if you need and if you want. And there are many applications of language model. The first is the text completion, which is I already showing here. There are other applications of language models, such as sentimental classification. You're given a text, maybe a reviewer of the film, and you try to classify whether this text is positive or negative about the film. The other application is name entity recognition. You have a really long text or paragraph. You're trying to find a object on that paragraph, place in that paragraph, or a person mentioned in that paragraph, and so on, many attributes if you need. That is called name entity recognition. A third application, that is text classification. You can imagine you make a call center, many customers call to you and they have lots of issues that need you to help. Maybe some issues related to ERP, some issues related to designer, some issues related to cloud. So you will have a language model to classify that issues belong to which department, and then you can the language model can connect directly to that department and say, okay, this is your issues, I think, and solving that issue thanks to the language model. And when you develop ChatGPT or any other large language model, the concept that you will face a lot, that is called tokenization. Why tokenization? Because when the user type a text, sometimes they make some typos, a mistake, such as instead of writing this is so tokenizing, they forgot the ng. So it make the word tokenizing become typos. So thanks to the tokenization, this sentence can be solved and can be processed. Without if we don't use the tokenization, this sentence will make noisy in our language model. So tokenized, technically that is a piece of text. Maybe that is a word, maybe that is a subword, or maybe that is a character. It may be the word like this is tokenizing. It may be a character like THIS, or it may be a subword such as this is, and tokenizing will be split between token and izing. So you can imagine if you make a typos in here, so you just simply don't use this, then use the word token. So your sentence technically is still have meaning. This is token. Then yesterday I also talked about the development of ChatGPT. Like I said, the generative AI ability depend on how they train and depend on the data set that they have trained. So if you want to use ChatGPT good, it is better to understand how ChatGPT was developed at the first place. This is the general approach, the general training pipeline of ChatGPT. It has four steps: pre-training, supervised fine-tuning, reward modeling, and reinforcement learning. Let's focus on the first two. The first one is the pre-training. This is the basic, the foundation of ChatGPT. That is the language modeling to predict the next token, like the word guessing game. You have a lot of data from the internet, really huge amount of terabytes of data. Then from those data set, maybe it contain low quality or high quality. It's have various of quality of data set. And OpenAI company, they train a language model to predict the next token. Given a sentence, try to predict the new word after that sentence. And they spend around thousands of GPUs and months of training in order to do that word completion and the next token prediction. And after they successfully finish that pre-training, they have a thing called the base model. And this base model is very important because thanks to that base model, they can apply to supervised fine-tuning. The supervised fine-tuning, technically, that is still a word guessing game prediction. But right now, instead of the input instead of some string, they try to reformat the dataset so that the input will be a prompt, something meaningful, and the output will be a response, something that can reply to that input. In this step, thanks to the base model, they can fine-tuning the base model with 1 or 100 GPUs and spend couples of days for training. If we want to fine-tuning the model, we can follow the supervised fine-tuning approach, that we labeling the data so that we have the prompt, which is the input, and the response, which is the output. And we do the supervised fine-tuning. And maybe we can spend days of training, maybe 3 days or 4 days, I don't know, depend on our skills. And the last two is the reward modeling and reinforcement learning. Technically, that is trying to make a ChatGPT generate good answer and good response. And so, like I say, the ChatGPT, their foundation is a word guessing game. So how can they turn a word guessing games into something that can helpful in real life? That they found out that base model can be prompt into a completing task, such as you have a large of context, which is your input, and at the end of your input is the word readers sleeves. And they found out that GPT-2 will predict the next word that technically answering the word readers sleeve. So although they are just trying to predict a new word, but the output after prediction is something really meaningful. So it's make a breakthrough. It's kick off the new era of prompting. So they found out that instead of just fine-tuning on the dataset, they will try to rewrite the input that's meaningful, and then they have the good output. Because fine-tuning, they spend lots of time. They spend a lot of time to prepare the dataset, and now they found out, okay, maybe just a little bit adjustment of the input, then you will have a good output. Then this is the pre-training step. This is the way that ChatGPT work in real life. You have for example, you have 4 input. Let's focus on the second line, which is the green color. So let's say you have 1, 2, 3, 4, 5 words. The ChatGPT will try to estimate the probabilities and predicts the probability of the next word, which is maybe 3,188. And then they append to the input, and they generate a new input. And with that new input, they try to keep predicting the next token, which is 513, and append to the new input, and then keep going to the next token and until the end. There are 3 hyperparameters that we should notice in ChatGPT. The first one is top P, the second is top K, and the third is the temperature. The top P, technically, they will select the top word having a cumulative distribution value larger or equal to a probability B. For example, if you set up P is 0.6, we will select the first 3 highest probability, because if you make a summation, this one sum to this one and sum to this one, you will get around 0.7, which is already larger than P. So this 3 word 3 and 4 is our candidate to select a new word. Another hyperparameter is top K. Top K, we will select keywords having the highest probability values. If we set up K is 2, then we will select 3 and N. So now we have a list of candidates, but we have to select only one word for the next token. So how can we select one word? They can determine one final token by using a thing called temperature. So with the temperature, they will scaling the probability values. For example, if you have 3 probability values and you draw on the graph, maybe the graph will look like this. But thanks to the temperature, they can scaling the probability value. If you set up the temperature is too small, maybe it's just 0.1, then this one, this word after scaling, maybe they come up like this. Yeah, it's become totally dominant. And then it will allow ChatGPT to select this word as the potential word for the next token. But if you set up the temperature is too high, then it's also make these other 2, the probability is quite large. So you can see that these 3 tokens, right now, if you set up the temperature is too high, they have quite similar probability. And both 3 have similar chance to being selected as the next token. So depend on the temperature values. Sometimes the ChatGPT answer will be really conservative. Sometimes ChatGPT answer will be more creative. So it will depend on your use case. The next one, like I mentioned, the ChatGPT quality right now depends on the way you adjust your input. So how to adjust your input? They have things called right now really popular. This is prompt engineering. Prompt engineering is a technique to adjust your input. So you can craft the input text to guide the model in generating a desired output. If you search the word prompt engineering on the internet, you see there are many thousand, not a thousand, but many prompt engineering techniques. Some of them I can mention, such as zero-shot prompting. The zero-shot prompting can simply explain that you write an input prompt with a leading phase, and then you expect the prompt to answer. This thing you can be understand like this one. The word where does she lives, and A, that is the leading phase, and you expect ChatGPT to fill in the blank, predicts the next one. So thanks to the leading phase, They can generate more thing meaningful. So the zero-shot prompting, it can help you to do that. And this has many applications such as sentimental analysis, even categorical classification. You can follow the zero-shot prompting. The second one is the few-shot prompting. The few-shot prompting it means that before generate the output, your input will provide a few samples in the input to guide the model towards generating a specific type of input. For example, you can have the text to say, what is 1 plus 1? Sometimes some people want the answer must be 2. Some people want the answer must be, the answer is 2. So it depends on the style of each person. So you can provide a few examples to guide the ChatGPT how to answer suitably. Then the few-shot prompting will guide the ChatGPT to answer based on the style that you need.
The short, the word short,
Yeah,
has a specific meaning in AI or just like an example?
it has a really strongly specific meaning in AI. In a specific in meaning of AI, the few-shot mean that learning through a few sample. So when I work in image classification, they have a problem called few-shot classification. As you know, if you use AI, you must have a lot of data set. But the few-shot classification means that your AI must work with few samples. So that is the kind of concept in AI. So few-shot in here means that you provide a few examples to the AI. Yeah. And the third approach is called a chain of thought prompting. The chain of thought prompting, they simply mean that before jumping to conclusion, you should generate more context before jumping to conclusion. You can recall the example I told you, Dehan Saram Dehanu, and you immediately know the next word must be role. But if I just say Dehan and ask you to predict the next word, maybe you have really lots of answers, possibly answer. So the chain of thought prompting, it can increase the quality of a large language model by providing more and more context. Some people can ask for about one issues. So before answering that issues, you can add relevant knowledge related to that issues, and ChatGPT, based on that relevant knowledge, will generate the corresponding response. So that is the chain of thought. The next one is called self-consistency. The self-consistencies mean that given the same question, you may have several output. Well, because this is generative AI, so one input, you may have several different output. But you can imagine that you run the Gen AI to the same question 5 times. Maybe 3 or 4 times you can say, looks like ChatGPT returns similar answer. Maybe one time is different, but 3 or 4 times is similar answer. So you can conclude that the word that appeared the most, it is the final answer. And this technique is extremely useful in RAG, because in RAG they have one drawback called position bias. I will talk about position bias later. And I apply self-consistencies to solve that position bias. The next one is the prompt chaining. The prompt chaining, technically, we combine multiple ChatGPT outputs. When we develop Dfocus GPT, we have only one prompt only. And that prompt, we ask ChatGPT to answer the question, analyze the question, make sure that question can be answered, generate the image, which means that many function in one prompt only. And sometimes it makes ChatGPT confused. They forgetting the function. Sometimes they answer but forget the image. Sometimes they add the image but forget the answer. It makes the ChatGPT confused. So instead of make everything into one prompt, let's follow the prompt chaining. So we combine multiple ChatGPT output, which means that we write one prompt for generate image, one prompt for answer, one prompt for analyze, one prompt for do blah 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 blah, and add together. The last one is tree of thought. Tree of thoughts, technically they apply to a complex problem that required several steps and consideration before reaching a conclusion. You can imagine the tree of thought. That is a tree. You have the problem. You think that problem can be solved in 3 steps. But if you go to the step number 1, you may have another 5 steps. And if you go to the step 1, if you go to another sub step, you may think that, oh, maybe there are 3 or more sub steps. So the tree of thought is a way you organize your problem into a tree by using ChatGPT. Then you use ChatGPT output to find a path. The path will be the step to solve the problem.
Question.
Yeah.
Sorry. Previous. Does ChatGPT can ChatGPT memorize?
The ChatGPT.
When I had a chain of chat with the ChatGPT, so when I have a third prompt, does ChatGPT memorize what I had done from first and second prompt?
Yeah.
It's just new.
The thing memorize is simply that the ChatGPT input already contain your first and second prompt. You can imagine that in
So
Chat.
he already learned, so he memorized.
Yeah, not kind of learn. They just add your first and second prompt to the input.
So he knows who I am. For example, if I say from the first prompt, I am a Korean, 40s, live in Seoul, do IT,
Yeah.
and what should I do? And the second question, I have a daughter, what should I advise to my daughter? So does ChatGPT remember who I am from my first prompt and
Okay.
discussion, or he doesn't know who I am?
If you talk about the session only, then ChatGPT can know. But if you refresh that session, ChatGPT forget.
Okay. Yeah. So in the session,
Yeah.
he has a sort of continuous.
Yeah.
Okay.
So that question explains the ChatGPT input. In practice, ChatGPT input contains 16,000 words. So when you write something to the input, ChatGPT generates the output. Then they append that output to the input. Then you submit the second input. That input will be also append to their previous 2 input, and it keep appending, keep appending.
Okay, got it. Thank you.
So if you refresh, of course they delete the input. Then they cannot remember anything.
And the second question is actually 2 questions.
Yeah.
The prompt is like typing with the keyboard.
Yeah.
To ChatGPT. What is prompt engineering? What I mean, what is so prompt engineering is sort of a build the code and then load to ChatGPT, or prepare data and upload to the ChatGPT, or prompt engineering itself is also just prompting.
Yeah, exactly. It's simple like that.
It's the last one.
Yeah, just simply typing.
So if you say I'm doing prompt engineering, so what I do is
Typing.
typing.
Yeah.
To train to use this type of techniques.
Yes, exactly. So in simple way, you just say, I'm doing prompt engineering technically, I'm just typing. But if you say more detail, is you trying to modify your input to generate the good output.
Yeah.
So the question will be how to modify that. Then you have these techniques.
These techniques.
Yeah. So let's go to retrieval augmented generation, or we call RAG so far. So let's recap about ChatGPT. ChatGPT, or generative AI, they generate output based on the data it had learned. So if you ask something about Python, you can use ChatGPT, or you use C++, you can use ChatGPT. But sadly, in Dfocus, we use Troya for ERP. And if you ask something about Troya in ChatGPT, they will think Troya is the historical event, not a programming language. The Troy, if you watch the movie in 2003, they think about an historical event or location. So if we want to leverage ChatGPT to defocus, how to make it happen? Because we use Troya or ERP in our defocus. Well, it's simply we just add these relevant data to ChatGPT and ask them to do text summarization. Because ChatGPT has the ability of summarize. You can adjust the prompt like, let's summarize this paragraph, and you add that paragraph, then ChatGPT output will be summarize the information inside the paragraph. So by doing so, we can utilize for our ChatGPT. Let's see. Let's see, someone said, what is Dfocus ERP solution? Of course, if you use the public API, ChatGPT cannot answer. But thankfully, we can adjust the input to answer as follows. This is the input. Answer the question based on the context. Your answer is now at most 700, something blah, 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 blah. Then I provide the context to them. So this is the context that I provide. And after this context, I add the question, what is Dfocus ERP solution? And I add the answer. So this is the entire input of me. And ChatGPT will fill in the blank, like keep writing after the word answer. So, and what is ChatGPT writing? This is the output. They will answer my question by kind of summarizing the context that I provide to them. So that is the basic explanation of RAG. You give the question, you give the prompt engineering to adjust the input, and you give the relevant content, and ChatGPT will answer. So in RAG, I can explain simply like that. So RAG means that given the question, you find relevant data, and then you add to the prompt, and done. So the question is how to find relevant data. In order to find relevant data, you have to implement a thing called search engineering, because only search engineering can find relevant data in your work. Then this is a session maybe you busy yesterday afternoon. So how to do the search engine? Maybe you are familiar with Google. Sometimes we search a lot on Google, and this is the basic technique that even Google also implement. There are two methods for retrieval. The first one is a word-based retrieval. The second is a vector-based retrieval. So let's go to the word-based first. The word-based retrieval, this is the basic, like really basic things that can do for searching. The user query, maybe someone can write "Chica please to sing song." Then in this word, you can maybe try to search all information in your database that containing the word "Chica please to" and "sing song." It's just simply string matching. Then the word-based retrieval will select all relevant information in your database that contain two words, "Chica please to" and "sing song," and take it out.
Not Chica please to or sing song.
Maybe or and depend on your method. So, but the word-based retrieval, like the word is like the concept I said, is depend on the word, depend on the exact word. So, if you have different expression, then you will fail. In life we have many expressions to one simple object, but if your database write in one style, but your question write in another style, of course they cannot match. So this also happened when I developed Kenya's ERP. So just someone can write collector Chuka and collector Dungu. This also happened in ChatGPT in my work in Guangzhou. So how to handle different expression of the same concept? They go to a second approach that is called vector-based retrieval. Instead of a word, let's use a vector. So right now they will represent text by the vector. They will have a model, AI model, to convert a text into a vector, represent a text into a vector. Such as now you have the word like dog, puppy, cat, or houses. Then you have an embedded model and convert into the vector. And so what is special in this vector? They have one thing is really special. That texts have similar semantic meaning will stand quite close together. Or we can say they have shortened in distance. Let's see the figure. If you plot all of this vector into the graph, you can see that puppy and dog, they're quite close together because they have similar semantic meaning. Houses and cat, they quite stay far from to each other. Similar, if you work with man, woman, king and queen, men and women quite close together because it belongs to the gender of the people. King and queen quite close to each other. So that is really good technique. So you imagine someone will search about queen. Sometimes the retrieval can return the information related to king, maybe the queen married to the king. And so that is the basic for vector-based retrieval. And then how do we apply vector-based method for retrieving information? This is the way we do.
Question.
Yep.
Is embedding comes later or?
Yep.
Yeah, I saw a lot of embedding in the documents. So do you have embedding contents in the later or?
Yesterday's slides. I will send to you the yesterday's slides.
Okay. So
actually, in this slide, I also talk about vector-based.
Yeah, that would be helpful.
Yeah.
So what is embedding? Documents they say embedding.
Yeah. The embedding is just the way you present your text by vector. Yeah. And one key important of embedding is that if two texts have similar semantic meaning, the vector represent will also have similar short distance. Yeah, when you study about in 고등학교, you study about vector and cosine similarity. Yeah, this will apply in this problem.
So what does embed or embedded means?
Actually, I'm not good at English in that word, but the thing that I can understand, just a way to represent a word, a text by a vector.
텍스트를 인베딩이라는 벡터로 컨버팅하는 과정이라고
과정을 인베딩이라고 해요.
네, 이제 저희가 이미지 같은 경우는 이제 사진은 RGB잖아요. 사실 저희가 닮았다라고 생각하는 것도 이 특징점들이 눈이 뭔가 작고 크고 그리고 피부가 까맣고 하얗고 색깔에 의존해서 그리고 분포와 이제 밀도에 의존해서 저희는 닮았다 안 닮았다라고 하는데 기존에는 이제 이미지만 닮았다 안 닮았다를 했는데 이제 텍스트까지 벡터로 변환이 가능하면서 그때부터 이제 그 텍스트 간에도 의미도 유사하게 판단할 수 있는 시대가 와서
이맨이라는 이 텍스트를 이런 식으로 멀티 디멘전 벡터로 바꾸는 요 과정을 인베딩이라고 한다.
네, 맞습니다.
그럼 요걸 인베디드 뭐
인베딩 된 이제 하나의
텍스트다 이렇게 표현하는 거죠.
네.
그러니까 문서에도 보니까 그런 말들이 많이 있는데 제가 오케이, got it.
Okay.
Thank you.
It's okay. Thank you, Jiman-san.
Thank you, Jiman.
So how can we apply a vector search in practice? So imagine this is your data set. The bottom. This is the real data set from Cloud Bubun. That from this data set, I will first, of course, preprocess this data set. And then for all of this text, I will represent it by a vector, applying embedded vector and store in our database. Then let's say a user send a request. The seed VDI say no IP available, please help. Then the process will, first I also convert this into vector. Then from this vector, I applied a vector calculation to all vectors saved in our entire database. Maybe I can apply Euclidean distance or cosine distance, the vector concept in high school. Then I find the shortest, and then I can have the candidate that can answer. These are the candidates that can retrieve. So you can see that this candidate is quite similar to the problem, the issues in our text. So the diagram, the right diagram, that is the basic Q&A with embedding, the basic diagram, and we may follow this diagram. That in this diagram, you can imagine this is our document, this is our original data. From this original data, we will save to database. We can save in vector form, or we also can save in text form because we have the database. For saving with the vector form, we have to add to embedding API. Then from this API, you will have corresponding vector. Then you will save to our database. And let's say this is a client. A client communicate with our application. They send a question. This question will also be vectorized. And it will make some, and we will do some vector calculation with our database. So which means that our database must perform a vector calculation.
So
and
embedding API means vectorizing.
Yeah,
API.
exactly. You like I'm using ChatGPT. I use the API. Input is the text, and the output will be the vector. And we do some calculation, and then we return a list of relevant information. And from a list of relevant information, we will ask ChatGPT to generate a completion or a guidance to the customer.